The Idylway copper-gold prospect here in Australia is the first real-world test of the spatial temporal Earth pattern, and the ability of that pattern to predict the most likely location of a world-class deposit. This is the usual disclaimer for this type of information memorandum. Groves, Conti, Goldfarb, Bronsky, and Riker made the following observation in respect to economic geology research in 2005. Their observations are directly applicable to the spatial temporal Earth pattern. Quote, over the past few decades, economic geology research has become very deposit-centric and forensic, with much of the research seeking to understand orogenesis through the use of sophisticated mineralogical, geochemical, isotopic, and fluid inclusion techniques. This has resulted in a much better knowledge of ore fluids and their sources, metal transport and deposition, and deposit-forming processes. However, these studies mostly help understand the mechanism of ore deposit formation, the how, but not the specific location of the deposit, the where. Thus, very few of the research parameters can be used directly to select specific terrains within specific segments of the Earth that can be intensively explored for world-class to giant mineral deposits. The spatial temporal Earth pattern is all about the where. And the where is the most critical factor. If there is no mineral deposit, world-class mineral deposit, beneath that segment of the Earth that you have selected for exploration, no matter how competent your geologist, your exploration team, you will never find a deposit. The location of the Idylway venture porphyry copper gold prospect in southeastern New South Wales. 2 contiguous exploration licenses cover the entire Idylway venture porphyry copper gold prospect. Note that EL 7334 is now EL 9445, exactly the same area, different license number. Since we were well aware that, especially in the Lachlan Fold Belt, copper-gold deposits could be buried at considerable depth, 500 meters to 1 kilometer. Hence, we employed an exploration technique, mobile metal-ion geochemistry, that would allow us to detect such buried deposits even at those depths. Using this technique, at least 6 areas of copper-gold anomalism have been discovered. Each of these covers an area of 1 to 3 square kilometers, spread over an area of 30 to 40 square kilometers, which is typical for a world-class porphyry copper-gold deposit. One can see here the gold mobile metal ion response ratio areas, the 6 areas, where the response ratios are greater than 10. Copper mobile metal ion response ratios generally complement those for gold. However, copper being more mobile in the superficial environment covers generally a larger area. The discovery of a porphyry copper-gold deposit at Caspiche in Chile is an example of the successful application of mobile metal ion geochemistry. The light blue color delineates the response ratio of 10 to 15 and is approximately 1.5 kilometers in diameter. Subsequent deep drilling revealed that the circular ore body coincides for the most part with the higher response ratios. This drill hole cross-section shows that both of the ore bodies were blind, did not crop out at the surface. The dashed line near the Earth's surface is the bottom of the leached capping. These pipe-like ore bodies go down to a depth of 1 to 1.5 kilometer, and the Idylway prospect is believed to have similar type ore bodies. Geological mapping of the Blacks Flat Diorite. Detailed geological mapping by consultant Michael Banks of the Blacks Flat Diorite revealed that it is a combination of multiple intrusions. It is a multi-phase intrusion, which is the characteristic of many diorites associated with porphyry copper deposits around the world. Our current exploration is focused on French's Paddock and Anomaly One. The location of those two gold anomalies. We will commence with French's Paddock. The copper-gold anomalism at French's Paddock covers an area that is 2.5 kilometers long and at least 1 kilometer wide. One of the features of French's Paddock that was especially attractive was the fact that surface samples, rock samples, assayed 10 grams a ton gold. The highlight of the drilling program was a 1-meter intersection that assayed 1.9 grams a ton gold. It was considered by the geologist Michael Banks to be a leakage vein, which is common over the top of porphyry copper-gold systems. The copper values peaked at 0.17% copper and do not explain the surface MMI geochemical anomalism. The abundant arsenopyrite intersected indicated that we were near the top of a porphyry system. It became obvious that we need to drill deeper. Halley's geochemical cross-section above a porphyry copper-gold system shows that the abundant arsenic in our drill holes indicates the current erosion level at French's Paddock. Let's now go on to the exploration results we have obtained from exploring Anomaly One. At Anomaly 1, the highly anomalous gold values, that is, with response ratios greater than 10, extend over a distance of at least 2.1 kilometers and varies in width from 200 meters to 1 kilometer. The gold zone is within a 2-kilometer diameter zone of copper anomalism. The most intense part of the gold anomalism coincides with a magnetic high. This is significant because deposits of this type, the presence of magnetic minerals, can mean higher gold grades. Modeling of the magnetic data by geophysical consultants Vidanovich and Stannard revealed that the likely depth of the source of the magnetism and a possible ore deposit is only 100 meters below the surface. Secondary copper mineralization in the form of malachite coating and chalcocite-coated pyrite was discovered at the surface by consultant Michael Banks. The obvious conclusion we can make in respect to Anomaly One is that the next stage of exploration requires drilling to depths of hundreds of meters of the coincident copper-gold magnetic anomalism. Notice that the Idylway Venture copper-gold prospect is proximal to well-developed infrastructure. As well, it is near and has much in common with the Cadia copper-gold mine, which is one of the top 10 in the world. Please note the location of the Cadia East and Ridgeway ore bodies in this plan view of the Cadia Porphyry copper-gold mine. As mentioned previously, the Cadia deposit is one of the top 10 gold mines in the world, with a production in 2021 of 764,000 ounces. The following tables show the historical production of gold and copper from the Cadia East and the Ridgeway mines. Production from the Ridgeway mine between the years 2002 and 2018 was 3,928,000 ounces of gold and 487,000 tons of copper. From the Cadia East mine from 2011 to 2020, metal production was 4,277,000 ounces of gold and 417,000 tons of copper. In the next few slides, we will show those many features that the Idylway prospect has in common with the Cadia copper-gold mine. Another important characteristic that the Idylway prospect has with the Cadia deposit is that they are both the same age, that is, 435 million years ago. The most recent age dating of the Blacks Flat Diorite was carried out by Bodorkas in 2013. The uranium-lead age of the diorite was found to be 435 million years ago. One can see on the Macquarie Arc summary time-space plot that this is also the age of the Cadia deposit. This time spiral, representing the entire history of the Earth from its very center 4.5 billion years ago to current, shows that the Idylway prospect and the Cadia mine are very old compared to the average, the mean age of porphyry copper deposits all over the world. Here in this detail we can see that the Idylway prospect and the Cadia mine came into existence before there were even any land animals here on Earth. The Shoshonitic character of rocks at both the Cadia mine and the Idylway prospect. A common theme of many epithermal and mesothermal porphyry-style copper-gold deposits worldwide is the association of these deposits with Shoshonites. And this is also the case for the bonzodiorites and quartz bonzonites at the Cadia deposit. They are all Shoshonitic. Consultant Professor Ken Cullerson found through unpublished data that the Blacks Flat Diorite is unequivocally, from major element and trace element chemistries, Shoshonitic in character. These graphs show the Blacks Flat Shoshonite is identical in chemistry to other mineralized Shoshonites within the Porphyry arc. Most diorites around the world are not pink in color, yet the Blacks Flat Diorite is pink, as are the other Shoshonitic diorites in the Porphyry arc that are mineralized with copper and gold. The pink color of the diorite is important because it indicates an oxidizing environment where the sulfate ion is the dominant sulfur species. Sulfate is over 10 times more soluble than sulfide, so a small amount of residual sulfate fluid can hold a large amount of copper. As Holliday 2007 pointed out, recognition of the significance of reddening of the feldspar was an important factor in the discovery of the Ridgeway deposit, as this feature helped with drill hole vectoring. The outcropping, pink, Shoshonitic Silurian, Blacks Flat Diorite. And my elegantly dressed field assistant and lovely wife, Jackie. The Blacks Flat Diorite has intruded the overlying Cambrian Ordovician Bullywara schists. Another example of the pink Shoshonitic diorite and its relationship with copper-gold mineralization is at North Parks, also within the Porphyry arc and the Lachlan Fold Belt. A study by A.J. Wilson found that the gold-copper ratio increased proximal to the Ridgeway ore body. The pipe-like body at the Ridgeway intrusive complex, which is mineralized with copper and gold, has a horizontal dimension of 200 by 100 meters and plunges to a depth of at least 1 kilometer. Following is a plan view of the 5280 level of the Ridgeway underground mine. The distribution of gold at that level. The distribution of copper at that level. The gold-copper ratio at that level within the Ridgeway underground mine. It is quite obvious how the gold-copper ratio increases as one approaches the Ridgeway ore body. The following slides show that there is a gold-copper ratio increase proximal to the Blacks Flat Diorite at the Idylway prospect. This shows that there are 9 highly anomalous areas with a gold-copper ratio exceeding 7, all proximal to the Blacks Flat Diorite. It is possible that each of these is a Ridgeway type porphyry copper gold deposit. This recent presentation, 2023, by Stephen Garwin, shows the latest data on the mineralization, hydrothermal alteration, magmatic conditions in porphyry systems. The next few slides will show that the list of characteristics as shown by Garwin, 2023, which are common to porphyry copper gold deposits, especially in the Circum-Pacific region, are also characteristics of the Idylway prospect. The causative intrusion, the Blacks Flat Diorite, at the Idylway Venture prospect is approximately 3 kilometers in diameter. The shallow levels of emplacement. This diagram by Simmons, 2021, shows the various major gold deposits around the world and the depths of their formation. The Cadia deposit formed at a depth of 2 to 3 kilometers, as is likely to be the case for the Idylway Venture prospect. The porphyritic texture of the causative intrusion. The porphyritic texture of the Blacks Flat Diorite. Multiple phases of intrusions. The Idylway Venture Blacks Flat Diorite is a multi-phase intrusion. There are several stages of hydrothermal alteration associated with each mineralizing intrusion. Since there are at least 4 phases of intrusions in the Idylway Venture prospect area, it is quite likely that the various stages of hydrothermal alteration will not be straightforward. The infrared spectral data for the French's Paddock gives some indication of the complexity of hydrothermal alteration. The complexity of the hydrothermal alteration mineralogy in French's Paddock can be seen here in the multiple highlighted alteration minerals discovered during the spectroscopic infrared analyses. Extensive development of fracture-controlled alteration and mineralization in both the porphyritic intrusions and especially at the Idylway prospect in the adjacent wall rock. The copper-gold mineralization at the Idylway prospect is essentially exclusively within the adjacent wall rock. Garwin, 2023, points out multiple examples of porphyry copper-gold mineralization within major world-class deposits, porphyry copper-gold deposits, with the mineralization adjacent to the igneous intrusion. A progression of hydrothermal alteration from distal propylitic styles through transitional intermediate argillic to late sericite, phyllic, and advanced argillic alteration types. The Blacks Flat Diorite formed 435 million years ago and has undergone multiple hydrothermal events associated with multiphase intrusion of the diorite itself, as well as subsequent multiple regional orogenic events. This is likely to explain the lack of observable progression in hydrothermal alteration even though there is abundant evidence for the presence of hydrothermal alteration mineralogy. This orderly progression of hydrothermal alteration is not seen at the Idylway prospect, since it is the same age as the Cadia deposit, that is 435 million years old, and very much an outlier. It is likely that because of the advanced age of the Cadia and the Idylway prospect, that everything that could possibly happen to a rock over 435 million years has happened at both of these locations. Metal zoning with a central iron, copper, gold core and proximal moly, gold, silver, lead, zinc, manganese. This is exactly the type of metal zoning observed at the Idylway prospect, with a more distant zone recognized as arsenic anomalism beyond the lead-zinc zone. And the final item in Garwin's 2023 list is, in summary, oxidized and hydrous magmas contribute significantly to form large, world-class, and rich copper-gold porphyry systems. As mentioned previously, the pink color of the Blacks Flat Diorite indicates the oxidizing environment in which it formed. This is the entire list of characteristics common to porphyry copper-gold deposits, especially in the Circum-Pacific region. The Idylway prospect has most of these characteristics. The Idylway prospect area was selected because of its proximity to the Deniliquin-Booligal ring structure circumference, and also to the known fact that terrestrial meteor impact craters have economic potential, with mineral deposits occurring along the circumference, that is the outer rim, of quite small modern impacts. The ring structure is located in southeastern Australia. The ring structure falls both within Victoria and New South Wales. This ring structure has both an inner and an outer ring, making it a complex type of meteor impact. The circle drawn here is only the inner ring of this complex structure. This total magnetic intensity map comes from a recent publication by Glikson 2022 titled The Geophysics and Origin of the Deniliquin Multi-Ring Feature in Southeastern Australia. The multiple rings of this feature are quite obvious. A field inspection along the circumference of the proposed Deniliquin-Booligal meteor impact discovered sheeted quartz veins with abundant arsenopyrite at a location known as Coleman's Hill. We eventually renamed this the Idylway prospect. Our exploration results to date in the real world, testing the spatial temporal Earth pattern, certainly supports, if not confirms, the prediction made by Robinson in 2007 that ancient meteor impacts provide the most likely locations of world-class deposits along the circumference of the circular template.